Bismillahirrahmanirrahim. Inshallah, let's put our knowledge to test then and do some questions with ellipses. Okay. Now, here's the question that we have before us. Identify the center, the vertices, the co-vertices, the foci, and major and minor axes, and then graph the ellipse. Basically, we're asked to just do everything. And the equation that's given to us is x squared over 36 plus y squared over 16 equals 1. We recognize that this is an ellipse. And in an ellipse, the general equation for an ellipse, if you recall, is x minus vx squared divided by a squared plus y minus vy squared over b squared is equal to 1. We know that this is an ellipse because both terms, the x term and the y term, are squared. Okay, in the parabola, one of them would be squared, either the x or the y would be squared, and in a circle they would both be squared also, but a and b would be the same, and that would be a circle. So the first thing we have to do is that we have to recognize that this is an ellipse and it is centered at the origin. So it's like x minus 0 squared over 36 plus y minus 0 squared over 16 equals to 1. You have to, the first thing, this is very critical to be able to graph this and recognize this in the proper form. We have to put this to be turn it into 1 if it's not. So it's a 1. So the center of the ellipse, it was easy enough. That's going to be our pseudovertex, okay? The center, or we affectionately call it the pseudovertex, right? And that's going to be, in this case, 0, 0. So this ellipse is centered around the origin right here. So let's label that 0, 0. Okay. And in this case, we recognize this a squared is 36. So this means a is square root of that, right? Is going to be plus or minus 6, right? So a is the length. If a is the length of the segment, then you can say a is 6. So a is going to be centered 6 units to each side. In a similar fashion, we have b squared is 16. From this, we get b is equal to 4. Now, I just take b as a distance, so it's absolute value. Okay, if you square root this, you get b is plus or minus 4. But if b is a distance, it's an absolute value of that, so b is 4. That's how I see it, anyways. So if this is the center, okay, and this is a horizontal ellipse, okay, then we're going to have to go 6 units to the right. So that's 1, 2, 3, 4, 5, 6 units to the right. That's A. So let's label this as 2, 4, and 6, and negative 2, negative 4, and negative 6 right here to get to the 2 vertices. Okay. So the vertices are 6, 0, and negative 6, 0. Now, if you didn't know that this was a vertical or horizontal ellipse, the easiest thing to do is just find the x and y intercepts, right? So to find the x-intercepts, you put 0 for the y. So if you didn't know, okay, so just do this. Just humor yourself and myself, just do this. So x squared over 36. Let's find the x-intercepts. To find the x-intercept, we substitute 0 for y. Right? So this whole term becomes 0. So x squared over 36 is equal to 1. X squared is going to equal to 36. And then you'll see x is plus or minus 6. Okay, then you can see the two x-intercepts are 6 and negative 6. Okay, so if you didn't know where the x and y intercept, if this was a vertical or horizontal, if you forgot, then you just substitute 0 and find the x and y intercepts respectively. Okay, that's reasonably easy and intuitive, and that actually demonstrates a very good understanding of what's going on here. But anyway, so the bigger number is the a, And if it's below x, it's a horizontal, and if the bigger number is below y, it's going to be a vertical ellipse. So this is going to be a horizontal ellipse. And b is 4, so you can go up to 4, so that's going to be one of the co-vertices, and 2, that's -2, -4, that's going to be the other one of the co-vertices. So let's label this. X is 0 and 4, and x is 0 and -4, so those are the co-vertices, okay? So now, so vertices are, okay, 6, 0, and -6, 0, or you can just say it's also, you know, plus or minus 6, 0. That's okay to do that too. And the co-vertices are x is 0 and plus or minus 4. You can say it that way. If you want to write it out, that's okay too. So now you're kind of ready to draw this ellipse, right? So it's going to start here, kind of like this. We'll do it the more artistic way, so you know, the best you can, like this, and that's going to be, you might want to, if you're a better artist than I am, you just want to do one nice smooth line like this, you know, that'll work too. And maybe I could make it reasonably civilized by erasing these extra lines. Alright, that's you're gonna have to be settled with that one. Okay. Perfection is the enemy of good. Okay, so here we go. So now we have our ellipse. We've drawn the ellipse. Okay. Easy peasy, perfection. Alright. So we have found the center. We label this. And we have found the vertices, co-vertices. Oh, now we have to find the foci. Okay. To find the foci in the ellipse, you have to understand this relationship. Okay. All right. So let's call this A, the red here, and it's the semi-major axis. And let's call the B over here like this, purple, and that's the semi-minor axis, or half the minor axis. The foci, as you recall, they always are going to be on the major axis. I don't know where they are. I'm just going to make it up. I'm just going to say they're going to be right over there somewhere. Okay, let's just say. So those are going to be the foci. The first one over here, F1, and the second foci, F2. Now this distance from the center to the foci, now that distance is going to be C. Okay. Now the relationship between A, B, and C, okay, is going to be the following. Okay. It's going to be, and this is very important, it's going to be B squared, okay, plus C squared is going to equal to A squared. Alright, now most textbooks will write this as C squared equals A squared plus A squared minus B squared, okay? So they will write this, and that's fine if you memorize it, that's cool. But it becomes, you'll see similar relationships will also occur with hyperbolas, etc. So and then you guess, is it plus, is it minus, is it plus or minus, right? You always get confused, okay? If you remember this, Hamza, it's good for you. But the way I see it is, you have to kind of make up a right triangle in your mind, okay? So if you make up a right triangle, the biggest side has to be the hypotenuse. The longest length has to be the hypotenuse, correct? So, of which one of these is the longest side? Okay, which one? Between A, B, and C, which one is the longest? Okay, which one is the longest? It's A, right? So A is going to be like the hypotenuse, okay, and B is going to be one of the legs, and C is going to be one of the other legs. So if you just intuitively think, between A, B, and C, if they were going to make a right triangle between the three of them, okay, it has to be the hypotenuse because it's the biggest side. Now once you get that, then you can see the Pythagorean theorem, B squared plus C squared is going to equal to A squared, which is what I have written here. So from the Pythagorean theorem, you get this, okay? And then you can solve this for C squared, and then become C squared is going to be A squared minus B squared. Now that is how I do it. because you'll see the relationship is different for hyperbola, and a lot of students would get this confused. Now that we know this, we can solve for c. So in our case, so let's find c, okay? So c squared is going to be, we know what a squared is, it's given to us, right? Okay, a squared is 36, b squared is 16, okay? And you can't flip it anyway because you're not going to be able to take square root of a negative number. So c squared is going to be equal to square root of 20, right? Alright, so now you take the square root of 20, so you're going to get c is going to equal to plus or minus square root of 20 like this. And you can simplify this. This is 4 times 5. So c is going to equal to plus or minus 2 square root of 5. Okay, in the simplest form. So now we know what c is. Now, from using that, we can write the foci. So foci are going to be equal to, okay, this one is going to be square root 2, 5. Okay, we're going to need some more delicate instruments here. Okay, so the first foci here is going to be the 2 square root of 5 and 0. That's over here. And the first foci is going to be that second foci is going to be negative 2 square root of 5 over 0. Okay, you get the answer. So the foci are going to be equal to plus or minus square root of 2 square root of 5 times and 0. Again, recall all the foci are always on the major axis. Okay, so the question had asked us to identify the center, which we did, which was 0, 0 in this case, which is an easy question. And the vertices were going to be these two over here, okay, which we identified, okay, and co-vertices we identified, foci we identified, and then we were asked to find the length of the major axis. Now, mind you, the length of the major axis is going to be 2 times a, right? So let me draw this out for you, make sure. So this is the major axis, right? It's 2 times a, correct? So the length of the major axis, okay, a was 6, correct, right? A was 6, so the major axis is going to be 12, and the length of the minor axis, okay, is going to be 2 times b, and b was 4, so it's going to be 8. Okay, so we did that. Always make sure you read the question and answer the question that they ask you, right? And then we graph the ellipse, okay? And to complete this and to be super mustahab, we just write the equation over here: x squared over 36 plus y squared over 16 equals 1. Okay, so this is an example of an ellipse. Now, one relationship that we learned over here was how a, b, and c are related. And for an ellipse, a, b, and c are related in this fashion, and you can intuitively derive from the Pythagorean theorem, like I have suggested over here. That's how I do it in my mind's eye. So c, the relation between a, b, and c for an ellipse is c squared equals a squared minus b squared. Inshallah, we'll do more examples. Until next time, as-salatu was-salamu ala rasulillah, alhamdulillah, rabbil alamin, assalamu alaikum.